Let's do this problem from your lab assignment, section 6.3, problem number 1. Use methods of cylindrical shells to find the volume generated by rotating the region bounded by the given curves about the y-axis. So we have the curve y is equal to 14e to the negative x squared, y is equal to 0, x is equal to 0, x is equal to 1. So x is equal to 0 and x is equal to 1 are vertical lines. And y is equal to 0 is the x-axis. X is equal to 0 is the y-axis. So it looks like we're going to get cut off. This looks like it's going to be like a bell curve going down. So it looks like if we take a look at this figure over here, it's the first quadrant. And it looks like what's shaded here is correct. However, is not a shape of a shell. So this is the other choice over here where we have the same shape and it has a shape of the shell. So I think this is going to be our answer. Let's take a look at what it says here. Rotating a vertical strip around the y-axis with the radius r is equal to. So let's take a look at the shell. The radius r is going to go from the y-axis in the x direction towards some x value. So I say the radius is going to be x, and the height of the cylinder, depending on where you are, will be from the x-axis to that graph. And this is the graph right here. So it would be this minus 0. That's x-axis is y is equal to 0. So this is just going to be 14e to the minus x squared. So that should work out. Let's check. Okay, looks good. Now we can say that the volume of the solid created by rotating this thing above the x-axis between 0 to 1 is going to be, well, the x limits are going to be from 0 to 1. So the formula is going to be 2 pi r times h. So r is going to be a function with respect to x. We found r to be x, and we found h to be that function that we have here, right? So this is our h. So we'll put that here, and that's 14e to the negative x squared. And so now this could be done with a u substitution. The 14 is a constant and go outside, but if we do a u substitution, there's an x here and there's an x squared. So if we let u equal to negative x squared, and then du is going to be negative 2 x times dx. The x times dx is here, and then there's going to be an extra negative 2 that we need to take out. And so we'll deal with that as we proceed to solve for this integral. So we have a negative 2 out here. The negative 2, that's part of the dx, needs to be divided out. So this is going to be negative 7 here. So the negative 7 can go outside and gets multiplied by 2, so that's back up to negative 14. So this is 14 pi. And then we have x is taken care of. We just have e to the u du. So that's the integral here. And then the antiderivative of that is e to the u. So we have a negative. There's a negative out here already, so we don't need to add that negative. 14 pi e, let's put a little space there, e to the u plus c. Now, I don't know if they're going to take this. We might need to put the e to the negative x squared back, but let's see. So it looks like that is exactly what they're looking for, at least at this point. And so that's the general antiderivative. and then we're going to replace it with going back to x. So this is where we put the x back. So let's say, again, don't forget the negative sign. Well, they already put the negative sign, so let's not put that again. So it's 14 pi e to the negative x squared. And we're going to evaluate this from 1 to 0. So when we put 1 in there, we're just going to get e to the negative 1. And then when we put 0 in there, we're just going to get, this whole thing is just going to be e to the 0 is equal to 1. So we have minus 14 pi. And then when we put 1 in there, we're going to get e to the negative 1. Or we can also say 1 over e. And when we put 0 in there, we're just going to get 1. And if you didn't notice, I factored out the negative 14 pi. All right, let's check it. And they wrote it a little bit differently, but it's all good. It's all the same. Okay, I hope that helps.